Hello everyone, thank you for taking quiz 6. So in this video, let's talk about the solutions. Okay, let's start from problem 1. So we have a function satisfying the following properties. F of a plus b equals f of a times f of b. And then we know f of 4 equal to 6. We want to solve f of 10. All right, let's use this property to rewrite f of 4. So 6 equals f of 4. And 4 equals 2 plus 2. So this is f2 times f2. So which is the square, f2 squared. So that means we can solve f2 equals square root 6 or minus square root 6. But we will see that it must be positive square root 6 because f of 2 is f of 1 times f of 1, because 2 equals 1 plus 1. And this is f of 1 squared, which is non-negative. So f of 2 must be positive square root 6. All right, now we can solve f of 10. So 10 equals the sum of 5 2's. So this is f, okay, say 2 plus 8, which is f2 times f8, right? And 8 equals 2 plus 6. So that's equal to f of 2 times f of 2 times f of 6. And then we can divide 6 into 2 and 4, which is f2 cubed f4, and f4 equals 6, right? So this is, well, I can keep doing this, and finally we just express this into f of 2. So basically we have the f of 2 fifth power, right? And now we can plug in the value of f2, root 6 fifth power, which is 36 root 6. Yeah, that's the answer. Problem 2. So we have a coordinate system and we want to count the number of integer points within this given triangle. So let me draw this triangle. This is origin 0, 0 and 11, 11. So maybe here is 22. So this point is 11, 11. So we consider this triangle OAB, right? So first we know that we want to count the number of points in the interior, okay? In the interior of the triangle. Not just, okay, on the boundary, the point on the boundary is not counted. Okay, let's see. How many points are there? So OA will have slope 1. AB has slope -1. So the highest integer point is the one right below A. So A is 11, 11. So the point below A is 11, 10. Okay, 11, 10. And the neighborhood points are on the boundary. Say 10, 10, or 12, 10. They are on the boundary. So we don't count these blue points. We just count these red points. And then let's count the point right below the red point. That will be 11, 9. Okay, 11, 9. And there will be two neighborhood points. 10, 9. This is a 12, 9. And then for the next 2 points will be on the boundary. So this will be 9, 9. And I think it's a 13, 9. Okay, 13, 9. So you will see the pattern. So for the next row, we add 2 more red points. So you will see that the next row will have 5 points. 5 points. Okay, so we have the total number of points is 1 plus 3 plus 5 plus more points, okay? All right, now, but we should count how many rows do we have, okay? Let's see how many rows do we have. For the last, okay, for the line OB, we have a point from 0, say 1, 2, something like that. And for the, this point will not be counted, but we will count the point above this row, okay? That's the last row we should count. This one is here. This is 1, so 1, 1. So this point should be counted, this red one. So this coordinate will be 2, okay, 2. And now let's see what's the last point here. This is a blue one, we don't count. And the red one is here, we count this point. So the blue one has x coordinate 21. So the red one has x coordinate 20, okay, 20, okay. So we count from 2 to 20. So finally we have 19 point. We have 19 point. So the total number for integer point is 1 plus 3 plus 5 plus 19. So this is the first 10 odd numbers. First n odd numbers, the sum equals n squared. So first 10 odd numbers add to 10 squared, which is 100. So the solution is just 100. Problem 3. So we want to choose 4 different integers from 1 to 10, such that we have the following equation: a plus b equals c plus d. The order does not matter. All right, here we need to discuss this sum. Okay, these 2 pairs numbers have the same sum. Let's discuss this sum. So this equals the sum s, right? So what kind of s could be possible? So let's try see what's the least value for s. Okay, we have number from 1, 2, 3, 4, 5, and 8. Okay, 6, 7, 8, 9, 10, right? So the smallest possible sum will be for the first 4 numbers. Okay, 1 plus 4 equals 2 plus 3. So the s should be at least 5. Of course, it can be larger, like 6. But what's the largest possible sum? Let's see. So largest possible sum is the case that we choose the largest 4 numbers, 7 to 10. And here we have 7 plus 10 equals 8 plus 9. So the largest possible sum will be 17. All right, now let's see for each of these s, how many ways can we choose these 4 numbers? Okay. So if s equals, say, equals 5, the smallest value, we must have only one choice. Okay. We can only do 1, 2, 3, 4. So let me do this way. 1 plus 4 equals 2 plus 3. So there's only one choice. Okay, here I do this way because we have 2 pairs. I want to choose 2 pairs from these 2 pairs. So basically I have to choose 2. So next, let's do s equals 6. So s equals 6, we should have number up to 5. Okay. For a larger number, we don't need it, right? So from here, we see that how many pairs do we have? We have 1 plus 5 or 2 plus 6. We still have 2 pairs. So if we want to choose 2 pairs, AB, 1 pair, CD, another pair, we want to choose these 2 pairs, we have 2 choose 2. Okay, 3 is not used. Okay, similar, let's do 7. 1, 2, 3, 4, 5, 6. Now we have 3 pairs. We have 3 pairs. But we only need 2 pairs, so we have a 3 choose 2. That many ways to choose A, B, C, D, right? Now, if s equals 8, we still have 3 pairs. So basically, we deal with some pattern. We don't need to write all cases out, but we find some pattern. For 5 and 6. They have the same numbers. For 6, 7, and 8, they have the same numbers. So we should expect like 9 and 10 should have the same number. And they will be 4 choose 2. Okay. So s equal to 9. So we have 1, 1, 8, 2, 7, 3, 6, 4, 5. So we have 4 pairs. So 4 choose 2. Similarly for s equal to 10 is also 4 pairs. 1, 2, 3, 4. Okay. But if s equal to 11, that's different. If s equal to 11, we have to use all numbers. Okay, we have to list all numbers. So 1 plus 10, 2 plus 9, 3 plus 8, 4 plus 7, 5 plus 6. Okay, we have five pairs. So we should choose 2 from 5 pairs. And now for larger numbers, we should be a little bit careful because we only have 10 numbers. So for example, if we want to count s equal to 12, s equal to 12, there will be, we still have 10 numbers. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So some numbers will be discarded. For example, we don't need 1, right? 1 and any number will be less than 12. So actually we need at least 2. So we can choose 2, 10, 3, 9, 4, 8, and 5, 6. So we'll come back to 2 plus 10, 3 plus 9, 4 plus, yeah, we have how many pairs? 4 pairs. Yeah, we have 4 pairs. So that's equivalent to s equal to 10. This is 4 choose 2, right? This is also 4 choose 2. So similarly, if you come to our other numbers, say s equal to 13, you'll see that this is still 4 choose 2. S equal to 14, s equal to 15, they are both 3 choose 2. 3 choose 2, because many small numbers will be discarded. And s equal to 16, s equal to 17, they are just 2 choose 2. And then we just add these numbers. So let me shrink this. So the answer will be, so for 2 choose 2, we have 4 times, right? So 4 times 2 choose 2, 3 choose 2, and 4 choose 2. Okay, and we plus 5 choose 2. So the number will be 50. So the answer is 50. Problem 4, so we have this quadrilateral ABCD, BC equals CD, and they are perpendicular. And we know the angle BAD equals 45 degrees. And then the area of triangle ACD is 18, that's given. So we need to find the length of AD. So the idea is as follows. So extend AD to the direction of D. Okay, and then we draw this altitude from C to AD. Let's call this foot to be E. And we also draw the altitude from D to AB. So the foot is F. Okay, but also we can connect DB, right? So here we see that triangle ADF and a triangle BDC, they are similar because both of them are right triangles and the angles are 45 degree, 45 degree, 90 degree. This is 45, this is 45, 90 degree, okay? Now I claim that triangle CED is similar to triangle DFB. Okay, first we know that both of them are right triangles. And also we need to prove another angle is equal. So here is the following. So we know that angle CDE plus angle FDB, this equals 180 minus 45 minus 45, which is 90 degree. Okay, and also we know that angle DBF plus angle FDB equals 90 degree, right? So we must have these two angles equal. Angle CDE equals angle DBF. Right? So these two triangles are similar. Now let's find the ratio of the side lengths. So the ratio of side lengths is CE over DF equals CD over DB. So we know that CD over DB is 1 over root 2 based on triangle DCB, okay? And that means CE is DF over root 2. Now let me set AF to be X, and we must have DF also equals X. So AD must be root 2X. By this ratio, we know that CE is DF divided by root 2. So it's X divided by root 2. All right, we are ready to express the area of triangle ACD. That's 1/2. I consider AD as the base and the CE as the height. So this is 1/2 times AD times X over root 2. So this is X squared over 2. But on the other hand, this value equals 18. That's given in the problem. So we solve that X equals 6. And then we can write out AD equals square root 2x. So it's 6 root 2. So the answer is 6 root 2. Right, let's do problem 5. So we have these three numbers form a geometric sequence, and we need to find the common ratio. All right, so here let me claim a statement. So if X, Y, Z form a geometric sequence, then we have the common ratio equals Y over X, but it's also equal to Z over Y. Okay, and then we can combine these two to get the same value equals Y minus Z over X minus Y. Okay, and in this problem, the last expression of common ratio is useful. So in this way, we can cancel this unknown A. So here, we just need to calculate this common ratio. Equals Y minus Z, so the second number minus the third number over the first number minus the second number. All right, so in this way, you just cancel A, and then this equals log 5 with base 4. So that's equivalent to natural log 5 over natural log 4. But natural log 4, okay, let me simplify later. This is natural log 5 over natural log 8. This is natural log 5 over natural log 2. Natural log 5 over natural log 4. Okay, maybe let me mark here. So in general, we have natural log a xy. This can be changed to a common base, natural log y over natural log x. So that's why I do it here. Now we can combine this. This natural log 4 equals twice natural log 2. Natural log 8 equals 3 times natural log 2, because 8 is 3 cubed, and 4 is, 8 is 2 cubed, and 4 is 2 squared. Right here is natural log 5 over natural log 2 minus natural log 5 over twice natural log 2, right? So we see that this is equivalent to 1 over 2 minus 1 over 3 natural log 5 natural log 2. This is 1 minus 1 over 2 natural log 5 over natural log 2. And this part we can cancel. So we got 1 over 6 over 1 over 2, which is 1 over 3. So the common ratio is 1 over 3. Okay, problem 6. We put these 9 numbers from 1 to 9 into this 3 by 3 boxes, right? And then we want to have, okay, what's the probability that the sum of each row and each column are all odd numbers? Right here, we see that from number 1 to 9, there are 5 odd numbers. There are 5 odd numbers and 4 even numbers. Okay. For each row, for example, each row, if the sum is odd number, we should have 2 cases, either 3 odd numbers or 1 odd numbers, because the even number doesn't change this parity. The even is oddness, right? So we have the following: each row or each column is either 3 odd numbers or exactly 1 odd number. Just 2 cases, right? And but we have totally 5 odd numbers. We cannot have every row 3 odd numbers, right? Or we cannot have every row just 1 number. So the only case is that we have 3 rows. One row has 3 odd numbers. The other 2 rows just have 1 odd number. Okay, and same for the 3 columns. We must have 3 odd numbers for a certain column. We don't know which one, but one column has 3 odd numbers, and the other 2 just 1 odd number. Okay, all right. We have that. This row and this column must have an intersection, right? So there exists one row and one column together covers all odd numbers. One row and one column. Contains all odd numbers. Okay. Now let's see how many ways can we choose this this row and this column. So let's choose this row that contains all 3 odd numbers, and then this column that contains all 3 odd numbers. So we have 3 times 3. We have 9 ways to choose this row and this column. Okay. Next, let's assign these numbers. Let's assign these numbers. So we assign this 5 odd number into these 5 boxes. Okay, we choose this row, this column. So we have 5 boxes. We assign these 5 odd numbers into these 5 boxes. We have 5 factorial ways to assign these 5 odd numbers. And then for the rest even numbers, we just put them to the remaining 4 boxes. So there are 4 factorial ways to assign these even numbers. So we want to count the probability. So we divide the total ways to assign these 9 numbers. That's exactly 9 factorial. So this probability equals this quotient. And then we can simplify this and get 1 over 14. So the answer is just 1 over 14. All right, let's come to problem 7. So we want to count the number of these numbers that it's base 7 representation if it's considered as base 10 representation is twice. So in other words, if we write this base from 7 to 10 is doubled, okay? So let's discuss the different cases. First, let's discuss how many digits do we have. So we consider 1 digit. If it's 1 digit, this number is, okay, this digit is A. If it's in 7 base, this is half of this in 10 base. But this is impossible, okay? This equation is just A equals 1/2 A. That just means A equals 0, but we are looking for positive integers, so no solution. No solution. Now let's consider 2-digit. 2-digit number. So let's say AB are the digits. AB is a 7 representation. If we understand this, if we can understand this as the 10 base 10 number, it becomes 1/2. Okay. All right. This is equivalent to the following. So 7A plus B equals, okay, this is twice, equals 10A plus B. And then this can be simplified as 4A equals, okay, so 4A plus B equals 0. But A, B are non-negative, so they must be both 0. But this is not a solution. We're looking for positive numbers. Okay. Now let's come to 3-digit. So we have A, B, C. If it's base 7 representation, that's just 1/2 of base 10 representation. And okay, this is twice equals that, okay? So this is equivalent to twice 49A plus 7B plus C equals 100A plus 10B plus C, okay? And let's simplify this. This goes to, this is 98A, so 2A equals 14 minus 10, so it's 4B plus C. So we have this equation. And of course, because A, B, C is base 7 representation, that means these digits are from the set 0, 1, 2, 3, 4, 5, 6. That's all. Okay, we have this many choices. Now, it's easy to see that C must be even. Okay, because C equals 2A minus 4B, that's even number. So let's discuss the value of C. If C equals 0, and that means A equals twice B. So let's see how many choices do we have. A, B could be 2, 1. Okay, here B cannot be 0, so A cannot be 0. So we must start B from 1. So it's 2, 1, 4, 2, or 6, 3. Okay, and now C equals 2. If C equals 2, we have A equals twice B plus 1. Okay, so AB could be 1, 0. B could be 0 now. 3, 1. And 5, 2. That's all. We cannot add another 1. Otherwise, A becomes 7. That's not allowed. Okay, now let's go to C equals 4. We will have A equals twice B plus 2. So AB could be, so B could be 0, okay? So that's 2, 0, 4, 1, 6, 2, and that's all. And finally, C equals 6. If C equals 6, A is twice B plus 3. AB could be 3, 0, and 5, 1. So we have here, we have 11 cases for 3-digit numbers. Okay, now let's see if we have higher or more digit numbers. And we will see that that's impossible. So for example, if we consider 4-digit number, that means A, B, C, D. If it's base 7 times 2, that becomes base 10. Okay, now let's write this out. That means 2 times 343, right? 49 times 7. Yeah, 343. A plus 49, B plus 7C plus D. This equals 1000A plus 100B plus 10C plus D. Now let's simplify it. So for A, we have, this is like a 686. So subtract, we got 314A plus 2B equals 4C plus D. This is impossible, okay? Because A is at least 1. A cannot be 0. A is at least 1. So the left-hand side is larger or equal to 314. But the right-hand side is small, okay, it's at small equal to 4 times 7 plus 7. They cannot be equal. And the similar idea applies to discuss more digit numbers. So they are all impossible. So we can only have valid numbers for 3-digit numbers. So the answer is just 11. That's problem 7.